Hello and welcome to our very first lesson on SAT review. We will be starting with the algebra domain of content and beginning with our linear equations and inequalities. Now there's a lot of terms that we want to make sure that we understand as far as vocabulary is concerned, so let's go through those real quick. Algebraic expressions, our first one. These are just numbers and variables connected by mathematical operations such as addition, subtraction, multiplication, division, and we have other operations as well such as square roots and exponents. Algebraic equation is a statement what two expressions have equal value. Okay, a statement that two expressions have equal value. So we take one algebraic expression, set it equal to another one. Now we have an equation. An inequality differs from an equation in that it uses an inequality symbol instead of an equal symbol. So we have the inequality symbol for less than or equal to, greater than, and greater than or equal to, rather than the equal sign. Linear equations are special equations where all the variables have an exponent or a degree of 1. And that's what we'll start with is linear equations, and we'll move into higher degree equations such as quadratic equations and so on. Terms are the add-ins of an expression, the things being added or subtracted together. Okay, it could be either addition or subtraction. We just use the term added both, such as the expression 3x squared plus 4x contains two terms. 3x squared and 4x, because these are being separated by an addition. Like terms are terms that contain exactly the same variable or variables raised to the exact same exponent, such as 3x squared and 2x squared. Those would be like terms because they contain the same exact variable raised to the same exponent. However, if we had 3x or 2x squared and 3y squared, the variables differ even though the exponents are the same, so they are not like terms. A constant is a term of an expression with no variable. It's just a number. Think about it. The word constant, it's always the same. 5 will always be 5. 7 will always be 7. 3/4 will always be the number 3/4. So now let's move into solving some linear equations in one variable, and we'll look at a few important terms that we need to know for that. When we're asked to solve an equation, what does that mean? Well, it means we have to use these properties of equality in order to isolate a variable. We want to think about what does the word isolate mean. Isolate just means to be alone. Okay, so to isolate is to be alone. So we want to get a variable by itself on one side of the equation, and everything else would be set to the other side of the equal sign, or even an inequality sign, and simplified as much as possible. So we usually end up with something like x equals, and then a bunch of other stuff, or even y is greater than or equal to, a bunch of other stuff. We want to isolate a variable. One of the properties of equality that we'll use, it's not a property of equality, but it's one of the properties we use is the distributive property, which is that multiplication distributes over addition. So when we have an expression with multiple add-ins, and that expression is being multiplied by a value, that multiplication distributes to all of the add-ins within the addition to give us a more simplified expression. When we undo the distributive property and go backwards, that is considered factoring. Another important property that we'll use is combining like terms. So it's using distributive property to add or subtract like terms. Again, through factoring, that's what we end up doing is we look and say, okay, well, I have these two add-ins that have a common factor, okay, making them like terms. So I can take the leading part of each of those terms and go ahead and undo that distribution and add those terms together, leaving that common term alone. Our properties of equality are the addition and multiplication properties of equality. Given that all the numbers we're dealing with are real, then if I start with two equivalent expressions, if I add something new or subtract something new to one side of the equation, If I do the same thing on the other side, they remain equivalent expressions. Same is true for multiplication and division. If I multiply the same thing on both sides of the equation, then it ends up being still an equivalent equation as long as C is not 0. Because if C is 0, then it always equals 0 or undefined, and it doesn't really do us any good. So we have these 6 basic steps for solving any type of linear equation, and this process actually works for a lot of different types of equations. And you may not use all of these steps, but it's a good idea to go through and check each of these. And the first one is to clear any fractions. This just makes solving a lot easier, and it's also the most important step when we get to rational equations much later. So we identify what the least common denominator is for all the fractions, and we want to multiply every term by that least common denominator, and that will simplify all the fractions so that our denominators will all equal 1. If we're dealing with decimals, we can multiply by a power of 10 equal to the longest decimal place value. And that will clear out all the decimals and again, make it a little bit simpler. Next thing is we'll use distributive property to remove grouping symbols. We'll then combine like terms. We'll use the addition property of equality to rearrange the equation so that variables are on one side and constants are on the other. Then we'll use the multiplication property to isolate the variable, and then of course we can always check our solution. So when we look at our first example, we see, okay, well, do I have any fractions or decimals to clear? No, so I don't have to do step 1. Do I have any distributive property to remove grouping symbols? No, so we don't need to do step 2. Do we have any like terms on each side of the equation? And we look and say, okay, well, 2x and 5, those aren't like terms, so we can't combine those, and 9 is only by itself. So you can see with this equation, we actually skip the first 3 steps of this process. It's going to be a much simpler one to solve. And then we can use our addition property to rearrange with variables on one side and constants on the other. So I look and I say, okay, well, I have 2x plus 5. I want to use my addition property. So in order to isolate my variable, I have to say, okay, well, what is the opposite of this added? Well, if I have plus 5, in order to get rid of and undo that operation, I have to subtract 5. And when I take a positive 5 and a negative 5, that equals 0 and cancels. And then on the right-hand side, I am left with 9 minus 5, which is 4. So we've got variables on one side and constants on the other. And now we can go ahead and use our multiplication property to isolate the variable. So we'll go ahead and say, okay, if I have 2 times a variable, in order to undo the 2 times the variable, we divide both sides of our equation by 2. 2 divided by 2 is 1, which cancels that out, leaving me with just 1x. And then 4 divided by 2 is 2. And we have our solution for x. Now, if you have time and you're working on the SAT, and again, you're racing the clock here, you can always check your answer. If you're unsure, you can substitute this value back in for your equation. And say, okay, well, I've got 2 times 2 plus 5, and let's see if that equals 9. Following our order of operations, we can simplify, and we see that, yeah, this is indeed the correct answer. So we'll go ahead and work through the next few. And again, I just want you to try and keep track and see which of these processes we are using and which ones we are skipping as we go through the process of solving. We'll start with B, and we'll say, okay, well, let's clear our decimals. Since our longest decimal is a place value of the 10th place, what we can do is multiply every term in our equation by 10. 10 times 0.6 is just 6. 10 times 2 is 20. 10 times negative 3.5 is negative 35c. Now we can use our addition property. We'll go ahead and subtract 20 from both sides of our equation. We get negative 14 equals negative 35c. And then we will use our multiplication property. If 35c, we will divide on both sides of the equation by negative 35, and that will leave us with c equals 0.4. Okay? On the SAT, when you're inputting fractions and decimals, Decimals are usually always accepted. If you do have a fraction, it needs to stay improper and simplified. So for C, we can go ahead and we have no fractions or decimals, so we can start with distribution. 2x minus 6 equals 5x minus 9. This one we'll want to go ahead and subtract 2x from both sides, and we get negative 6 equals 3x minus 9. We also will have to do that step again and add 9 to both sides to get variables and constants away from each other. And then we can go ahead and divide both sides of the equation by 3, and x equals 1. For question D, we can combine like terms. On the left side, we have negative 4x plus 5x, which just gives us x. And on the right, we have 9x and negative 7, which gives us 2x. Then we can go ahead and use our addition property. We'll subtract x from both sides to move it to the right. I'll add it and do the same step together. We'll subtract 3 from both sides to move it to the left. And that way we end up with negative 4 on one side and x on the other. And now we have our solution. Let's go to E. So now we have fractions, so we need to identify what our least common denominator is. Well, we're going to look and see that, okay, we've got a 3, a 4, and a 6. So 3 has multiples of 3, 6, 9, and 12, and so on. 4 has multiples of 4, 8, 12, and so on. 6 has multiples of 6, 12, 18, and so on. We're looking for the smallest number that all 3 of these have in common, which is 12. So our least common denominator is 12. We'll go ahead and we'll multiply everything by 12, giving us 12x over 3 minus 12x over 4 equals 12 over 6. Each of these fractions will reduce. 12 divided by 3 is 4x. 12 divided by 4 is 3x. 12 divided by 6 is 2. Then we can just combine our like terms, and x equals 2. Here we only have one denominator, so we can go ahead and multiply everything in our equations by 5, which cancels it out on the left. Here we'll have to apply our distributive property because we have more than one term on the right, and so we have 10x plus 30. And then we can apply the distributive property on the left. 3x plus 9 equals plus 30. We can use our addition property, so we'll subtract 3x from both sides, and we'll go ahead and also subtract 30 from both sides with the constants, and that will move them to opposite sides. So we have a negative 27 equals 7x. And I'm running out of room, so let's move this up here a little bit. We can use our multiplication property of equality, divide both sides by 7, so we're left with negative 3 for our value of x. G, what we'll take a look at is we'll go ahead and start by using our subtraction or addition property of equality. We'll subtract 3 from both sides of the equation, but what happens here is that now our variable gets canceled out. So what we're left with is negative 7 equals 1. With this happens, we have to look at, is this statement true? Is this statement true? Well, is negative 7 equal to 1? Clearly it's not. It is not true. And so when this happens, our variables cancel and we're left with a statement that is always false. What we have is no solution. It does not matter what value we plug in for x, we will never get an answer that works. And then for our last one, let's go ahead and we'll apply distributive property. 5x minus 5 equals 2x plus 2 plus 3x minus 7. We can group like terms. Move here, and we've got like terms here. So we're left with 5x minus 7. 2x plus 3x equals 5x, and 2x minus 7 equals negative 5. And then we can use our addition property. minus 5x minus 5x. And the same thing on this question is going to happen as we did with the last one. Our variables cancel out, and we're left with negative 5 equals negative 5. So again, we ask ourselves, is this statement true? And yes, it is. Negative 5 equals negative 5. And so what this means is it doesn't matter what value of x we plug in, it will always be a true equation. And so this, instead of being no solution, we actually have all solutions. Our solution is all real numbers. Our solution is all real numbers. Let's continue by using equations to evaluate other equations. And so what we can do is we can establish what something is and use it to continue to solve. So here we have the equation 2x plus 5y equals 1. And x equals 3, we want to solve for the value of y. We can do is say, well, if x equals 3, I can take this x and just replace it with 3. We're left with 2 times 3 plus 5y equals 1. And now we can work through the process of simplifying and try to solve. 6 plus 5y equals 1. We'll use our subtraction property. 5y equals negative 5. And then we'll go ahead and divide. I'm running out of room, so let's rewrite it here. Divide both sides by 5, and we're left with negative 1. Here we have one that's a little bit more complex, and it says, okay, well, if 2x plus 1 equals 5, what is the value of 8x plus 4? Since we have an equation here, we could actually go ahead and solve for x and figure out what we could plug in here. There's also another way to solve this problem, and why don't you try and see if you can figure it out before I tell you. So here we have 2x plus 1 equals 5. We'll use our subtraction property. 2x equals 4. Divide by 2. X equals 2. And then we can go ahead and substitute it in. And we'll say, okay, we've got 8 times 2. Let's use a different color here. 8 times 2 plus 4. 16 plus 4 equals 20. So we can evaluate 8x plus 4, given that we know that 2x plus 1 equals 5. That's our solution there. Now, alternatively, what you could do is look and say, okay, well, 2x plus 1 looks kind of similar to 8x plus 4. It has a very similar relationship. How do you get from 2x to 8, and is it the same way to get from 1 to 4? If we take 2x plus 1 and we multiply it by 4, we get 8x plus 4. Well, since we have an equation, we can use our multiplication property of equality and say, well, if I want to multiply the left side of my equation so that it looks like something else, I can also multiply the right side of my equation by that same thing. Multiply the left by 4 and the right by 4, and we end up with 20. And oftentimes you'll see that some type of relationship is present. You have to remember the SAT is all about answering questions as fast as you can. You get on average about 2 minutes per question. Sometimes they might even be a little bit less. Last thing that I want to cover right now is the same concept but with linear inequalities. The addition and multiplication properties are the same. If we have an inequality, we can add or subtract the same thing to both sides, and it remains a true inequality. But the multiplication property changes a little bit. If what we're multiplying by is positive, then there's no difference between one inequality to the next. You see we have A is less than B. A times C is still less than B times C. However, if what we're multiplying or dividing by is negative, then we have to change the inequality from facing one direction to the other. End up going from a less than sign to a greater than sign. So we just have to keep that in mind whenever we're using multiplication. So let's go ahead and do the same process. We'll start with distributive property. We don't have any decimals or fractions. Negative x plus 3 plus 2 is less than or equal to 6x minus 15 plus x. Combine like terms. Negative x plus 5 is less than or equal to 7x minus 15. And then we can go ahead and use our addition property. Now, if you're very, very careful, you can oftentimes make sure that you don't end up with a negative so you don't have to remember to flip the sign. So I usually like to use the addition property on the smallest value. So we're looking at negative x versus 7x. Negative x is smaller. So what I'm going to do is I'm going to go ahead and add the smaller value. We would use the add or subtract the smaller value from both sides of the equation so that I know I'm left with a positive coefficient on my variable. 5 is less than or equal to 8x minus 15. And then we can go ahead and add 15 to both sides. So we have 20 is less than or equal to 8x. All right. Now what we're going to do is we're going to go ahead and divide both sides by 8. And we're left with 20 over 8, which reduces down to 5, or 2 is less than or equal to x. So now what we have to do is remember, though, that inequalities, the order kind of needs to make sense. So oftentimes what we do is we rewrite the equation. We'll rewrite the equation so that the variable is on the left side. And so what we'll do is we'll flip it and we'll say x instead is greater than or equal to 5 over 2. Notice how it's open towards the x and it remains open towards the x. Next one, we've got a compound inequality, but the same idea is going to take place. We want to get the variable isolated. So the first thing we'll do is get rid of this constant. We'll subtract 5, but instead of doing it from both sides of an inequality, we do it from all three sides of an inequality. So it cancels out from the middle. We're left with negative 2 is less than negative x, which is less than 4. Now we need to divide by the negative 1 coefficient. And because we're dividing by a negative value, all of these inequalities will change directions. So we're left with an x in the middle, a positive 2 on the left, and a negative 4 on the right. And again, with compound inequalities, we like to have the lower values on the left. So we're just going to flip it all around. And we're going to say we're going to have negative 4 on the left. The inequality opens towards the x, so we'll flip that around so that it's still opening towards the x, and then opening away from the negative 4. And now we want it to open towards the 2, so we'll flip it around so that it's opening towards the 2. And our last one, we'll do the same thing. We'll apply our distributive property in order to solve. 2x plus 6 is greater than 2x plus 1. Let's use our subtraction property. We subtract, and we end up with a similar situation as we did up earlier here, is that now we're left with no variables and an expression. And again, we ask ourselves, is this statement true? If the statement's true, then we have all real numbers. All real numbers, which is the case here. This is a true statement. But if the statement was false, like we had up here, then we would be left with no solution. Okay? And that is it for the basics of solving linear equations and inequalities.